A right circular cone, diameter of base 60 mm and height 70 mm, rests on its base on HP. A section plane perpendicular to HP and inclined at 45 degrees to the VP cuts the cone and is 10 mm in front of the axis. Draw its top view, sectional front view, and true shape of the section. So, whole lot of things have been given to us. Object obviously is a cone. The dimensions of which are base dia 60 millimeters and height or the axis length 70 millimeters. Now there is this condition that has been given to us, resting on HP on its base. Now guys, just you need to think about this. If the cone is resting with its circular base on HP, then one thing is for sure, that the true shape of its base can only be seen from the top, and hence you have to begin by making the top view first, and accordingly its front view is going to be made. All right, now there is this cutting plane detail. Okay, so cuts the pyramid at 45 degrees and passes at a distance of 10 millimeters from its axis. So when you speak of an auxiliary vertical plane, just think about this. This plane in fact is perpendicular to HP. Okay, so a plane perpendicular to HP will appear as a line in from the top. Just think about this. Okay, and that line in fact would be making 45-degree angle, and at the same time it would be passing from a point that lies 10 mm from the axis. All right, so we're going to be making sure that all of these details reflect perfectly in our drawing. And now the solution again has been divided into three phases. First phase is going to be all about the positioning of the object with reference to HP and VP. Second phase is going to be all about the cutting plane details, and in the third phase we'll draw. Yeah, okay, so let's go ahead and see what phase 1 has to offer. So guys, this in front of you is the cone, and we know very well that it is resting with its base on HP. Okay, then one thing is for sure, that the true shape of this circular base, okay, can only be seen from the top, and it's gonna look something like this. So this is how you need to begin. Below this XY line, you're gonna make this circle, okay, and accordingly its front view gonna be made. It's gonna look something like this. All right, now we have a cutting plane. All right, so that cutting plane, let me slightly tilt this. Okay, all right, let me slightly rotate this cutting plane, because this cutting plane has been kept at an angle of 45 degrees. So let us see how it looks from the top. Okay, and there we go. All right, now there is this cutting plane, this yellow colored plane that you see. Okay, and when you try to look at this from the top, you have this angle as 45 degrees. Okay, now what we're going to do is, this is the top view, this represents the sectional top view, and when you want to have the true shape of the section, you're going to have to look at this from over here, exactly in direction perpendicular to that of the cutting plane. Okay, and it's going to look something like this. This is going to be the true shape of section. All right, so let's initially start by making an XY line, and we know very well that this cone is resting with its base on the HP. So the true shape of the base is going to be seen from the top, and hence we start by making a circle. Okay, in the top view, let's divide this circle into 4 equal parts, and this circle is going to be having a dimension of, radius is 30, diameter was 60, and hence radius is 30. Let's divide this circle into 8 equal parts. Okay, now let's give numbers to each and every point that we have made. Okay, so like starting from this point, 1, 2, 3, and so on. Now when you try to look at this from the front, let's have projector lines from 1, from 2, 8, like this, and these are the intersection points at the base or in the front. This is going to be 1 dash, this is going to be 2 dash, 8 dash, and so on. Now we have this axis, all right, and this axis length or the height of the axis has been given as 70 millimeters. Now let's draw the generators from 1 dash to O dash, from 2 dash to O dash, and then from 8 dash to O dash, and so on. Now there is this point through which this cutting plane is passing. You see this? All right, see this point? Let me show that once again. Now this point is at a distance of 10 millimeters in front of this axis. We have an axis over here. In the front view, you can see this axis, and this axis apparently looks like a point in the top. So through this point, a cutting plane would be passing something like this, and the angle that it's gonna make, this cutting plane is gonna make, is gonna be 45 degrees. All right, so let's darken the portion. You can see this, I've already darkened the portion falling immediately behind this cutting plane. Okay, so that is the portion which is remaining. Okay, this is the cutoff portion. Now we're going to write the intersecting points, like somewhere along this circular base between 2 and 3 we have a point in the form of A. Okay, like this is going to be point A, and somewhere along this generator O3 we have point B, generator O4 we have point C, generator O5 we have point D, and finally again somewhere along this circular base between 5 and 6 we have point E. So all of these intersecting points are going to have their impact in the front view also. So let's say we want to fix this point A. We know very well that point A lies between 2 and 3. So in the front view it's going to lie between 2 dash and 3 dash, and that's point A, the precise location of point A. Now the issue is we want to fix the location of point B. We know very well that point B lies in the generator O3, generator O dash 3 dash in the front. Okay, but when you try to draw a line from B, it overlaps this generator. All right, but we want an intersection. How can we do so? So the trick is you need to take this O as the center and OB as the radius, and you need to rotate this in the clockwise sense until you reach here, a quarter circle you can say, and then you need to go upstairs until you reach here and then turn towards the right, and here you have point B dash. Okay, and then for point C it's pretty easy, O4, O dash 4 dash, and let's project a line. Here we have point C. For point D let's project again, this is going to be point D dash, and finally somewhere along the circular base between 5 and 6, between 5 dash and 6 dash we're going to have this point as point E. And when you join all these points with the help of a smooth curve, this is what you call the sectional front view. Let me show that once again. Hatching, and now the portion which can be seen in fact has to be darkened. Okay, the outline, this outline, I have to darken this, right? Something like this. So this was all about the sectional front view, and this is the sectional top view. We'll now go ahead and make the true shape of this section, and for that we have to look at this object from over here. So let's have an auxiliary plane, okay, onto which the image of this section is going to be made. All right, and we have to draw perpendicular lines starting from A, B, C, D and E, something like this. And for locating the precise location of point A in this true shape, we have to take the distances from XY line and put them up with X1, Y1 as reference. So point A, this is the point A, lies exactly on this XY line. So it is again going to lie exactly on this X1, Y1 also. So this is the location of point A dash. Coming downwards here, we're going to have point A. There you go. For locating point B, keep one leg of your compass here, other leg over here. Then with this guy X1, Y1 as the center, you need to put an arc, and that's point B. Let's repeat the same process for C. Keep one leg of your compass here, other leg over here. Then with this guy X1, Y1 as the center, put an arc, that's point C. Let's repeat this process for D also. This is going to be point D. And finally E point is not at a distance. The distance is in fact 0 from XY line. So again point E is going to lie here at a distance of 0 from X1, Y1 also. That's point E. And when you join all of these points with the help of a smooth curve, this represents the true shape of the section. Alright, so guys, that was all from my side. If you have any doubts or queries, do write them down in the comment section below. I'll be very happy to answer them. And if you find this video helpful, do give it a big thumbs up.